exam structure. I can do that. Okay, so let's talk about the exam structure really quickly. And let me just make sure I didn't pointers chase. Yeah, we uploaded to a learning site. I might be able to no, so things he explained to me on the exam about that. The recordings to drop the learning commons where the if not I can try to find the exam structure. So he's gonna give you guys 15 each different one that's 12 points. Is to just get if you get 150 out of any 100 is 100. Final points you can get 150 means you get 149. 50 it's still 100 because you're just looking at the top number. If the top number is over 100, it's 100. Now his curve depending on how the class does is square root your score. So say you got a 64, square root that and then multiply on how the class does. You're either going to multiply by 10, which is an 80, or you're going to multiply by 12, which is a 96. Okay, class does worse, class does bad, it's going to be 80. Okay, things have parts to them. So for question 3, you can have part A, part B.
I think your connection is kind of bad because like you're lagging.
In order, did you guys hear me? Or is it
You're
just
kind of
the
lagging.
iPad?
Yeah, you're
Give
kind
me
of
1
lagging.
second. Is it better now?
I think it's a bit better. Yeah.
Okay. If not, I can try to fix it. But okay, it might have just been my headphones. Okay, perfect. In order for you to get credit for part A, you have to get B correct. So say part A says, I'm just gonna give you a random example. Something along those lines, okay? You get the answer. Here's the answer. This is the answer. But here it says Y. If you don't get the Y correct, then you get the entire question wrong. It doesn't matter that you got part A correct. Does that make sense?
Wait, so how would I like explain that?
How'd you what?
How would I explain that?
Well, this is just a random example. I can give you one. Let me think of one that I can give you. Okay, I can give you this one. I think it's in the book actually. Okay, say we have 8 queens with go-tos, okay? So I tell you, and this is the 2D version. And we'll go over all of this also in more depth, but just as a random example, I say if C equals 8, go to, and then I tell you if R equals 8, go to, this is part A. Part B is explain both. Okay, so if the column 8, where am I going to?
Print.
I think to the next row.
So if my column equals 8,
Print, right?
sorry?
Print.
It should be that.
Print, yeah,
Good.
print.
We go to print. Now, your explanation for that is because you're off the board. You're off the board on the right, which means
Wait, so you just like write print and that's it? Like that's all you write?
for part A. Yeah.
Yeah.
For part B,
And
you
what
say you're
about
off the board on
what
the
about the
right.
second part for part A?
This one?
Yeah.
Yeah, I'm gonna get to that in a second.
All right.
You're off the board on the right, which means you placed a queen in every column. That doesn't conflict. Okay, something like this would be fine. You can say it's shorter. Now, if you get this explanation wrong, completely wrong, then part A is wrong also. It doesn't matter. He'll write explicitly in the question, he'll say, if you get the explanation wrong, then the entire question is wrong. Okay? For part A, the second
Wait, how much
version,
points would a question like this be?
if it has an explanation, it's usually worth a little more because you don't have to explain every question. So if you have, for example, if you
10
have an
points?
explanation question, this would probably be worth 10 points, I would assume.
All right. And like, would I have to write the whole 8 weeks problem on the test or no?
No, his test. So again, part of his structure, a lot of it, maybe like 50% or 60% is memorization, and then the other 40 or 50% is just riddles. So it's
Like what do you mean by riddles?
he'll give you a completely different riddle every time. Those we usually don't go over because it's unpredictable. It's usually riddles that make you think a little bit more, but it's random every time. There's no pattern to it.
Like what would it be about usually? Like about pointers and stuff or like
No, literally just riddles. He'll ask you to figure something. So he'll tell you, what if you get the explanation correct? Then you would get partial credit, Jalen. If you, so for example, a riddle would be like, maybe you guys are familiar with it. I know he hasn't used it in the past, but it's like this, like figure out who's the painter, the banker, and the something. Let me see if I can find it.
but what's the point of that? It's like a computer science class.
His idea is to make you think through brute force also, just like how a computer would run an algorithm. Why does he give you it? Yeah, it's a non-coding related riddle. Why does he give it to you? I don't know. I'm not 100% sure why he would. Let me see.
Is it
He's
just like
setting
to
us up
test
for
logic?
failure.
Yeah, these are exactly, they're logic puzzles, exactly. Let me see if I can find it. Yeah, here it is. Okay, so I just looked it up online. It says, okay, here's a random example. Clark, Daw, and Fuller. Let me screenshot this into the chat. Here, something along these lines. Okay, I just put it into the chat. Let me know if you guys see them. Hugo, that grading system is only for questions with explanations. If he doesn't say explain, you don't have to, and you can get full credit for just writing the answer.
Wait,
Okay.
say that again?
If the question doesn't say to explain, then you don't have to explain. You can just write the answer and you can get full credit for it.
All right, got it.
Okay.
But for the second part, what do I do? For part A?
For part A,
Yeah.
this would be go to backtrack.
And then
Why?
what
Because
would be
you
the
tried
explanation?
every row here, and you get off the board on the bottom. So you get off the board
That means you did something wrong.
on the bottom. It doesn't necessarily mean you did something wrong. You just weren't able to place a queen that didn't conflict. So you have to rearrange one of the other queens from the previous columns, which is just what backtrack does.
Got it.
Okay. Now for the logic puzzles, I just put one in the chat. It says Clark, Don, Fuller make their living as a carpenter, painter, and plumber, though not necessarily
Could you go
in
up a
that
bit?
respective order. And then he gives you just a bunch of different hints, and he asks, what is each man's occupation? So you have to tell him Clark is whatever. Say Clark is the painter, Daw is the carpenter, Fuller is the plumber, and you have to explain why. That would be an example of a logic riddle. Any code? Yeah, so he might make you write an okay function for the 8 queens 1D no go tos. He can make you write the stable marriage okay function. He won't make you write an entire program, but one of the functions you've had in the past is fair game to write. We can go over how to write one, the logic.
Wait, so we basically have to memorize all the 8 queens and all the, what's it called? Stable marriage?
Every single program he gave you, 8 numbers and across, 8 queens. Yes, you have to memorize all of that.
Just the functions though, not like the int main and everything.
No, so he might give you some fill in the blanks. If he gives you fill in the blanks, you're gonna have to write down. So like this, for example, this could be a fill in the blank in the main function. You might have to write down whatever he takes out.
Like it's not gonna be something longer than this though, right?
No, meaning he's not making you write an entire program, but you have to know how each program works.
Wait, does he make us write like a different type program for like something else?
What do you mean?
Like, I don't know, like the digital odometer or something?
No. You don't have to write any entire program. Only at most he'll make you fill in the blank for the digital odometer or write the OK function for that because it's the same one used in the brute force.
Wait, there's a function for the digital odometer?
There's a function for the 8 queens brute force.
Oh, that one, yeah.
Okay, let me just make sure I didn't miss anything in the chat. No, we don't backtrack for both. The first one we print, the second one we backtrack. After we print, yes, we would have to backtrack because we want to find another solution. That's why. Do we also need... No, you don't need score the race or perfect square assignments for this midterm. As far as I know, will there be questions about programs we haven't done in class? None that are coding based, but again, he might ask you the logic questions, which those might be on the exam. Okay, so that's the exam structure. Let me know if you guys want any other clarification about that. Yeah, correct, Giovanni. Exactly. When we put all 8 queens, we print the board. And then what we do is we backtrack to find another solution. After 92 backtracks, After 92 times of the solutions being backtracked, then we just return 0. Once we return 0, that means we can't backtrack anymore to get a different solution. Brute force. What do you mean by configuration? Converting binary I can do. I'm not sure what you mean about configuration. Let's see. Should we prioritize on learning and understanding? I wouldn't prioritize it, but I would just understand the basics of it. You're comfortable with the programs I've done so far? Yeah, if you're comfortable with that, that's about 60% of the exam. And with his curve, that brings you to about a B- or a B. So, and then you can just try the other.
Wait, how do we convert binary?
So you just divide by 2 the entire time. I can give you guys an example. But if you do it for one solution, will I get any credit? If you do what for one solution? The 8 queen problem. I'm still confused. What do you mean if you do the 8 queens problem for one solution? What he'll ask you for the 8 queens problem is he'll literally write down. Oh, he's not going to ask you to iterate through the 8 queens problem and find one solution that works. He's just going to ask you for the logic behind the 8 queens problem. Almost like this. Like, if C equals 8, go to print. Why am I going to print? Or he might say, if C equals -1, what happens? And you say, return 0. Because this means you weren't able to find another solution, right? You kept backtracking and now you're off the board on the left, which means that you have no more solutions to print, so you just return 0. Okay, is that good?
So how much would I have to get out of 150 to get like a C?
So you can get, so how it works is you can get 150 out of 100, but anything here above 100, 100 plus is still 100. It doesn't matter. The denominator
Like
stays out of
basically you have
100.
a higher chance of passing with a grade like that, right? Like
Yeah, he
out of
tries to give you guys as many points as possible to get some questions right. So if you get a 79 out of 100, you just got a 79. Okay? If you want a C after the curve, what is a C? A C is 75. Give or take, I would assume, yeah. So you need somewhere around a 60 before the curve.
That's 60 before the curve.
Yeah, I'm trying to think.
So you gotta get like 30% of it right.
Yeah, like if you get 49 out of 100, square root 49 is 7. And then multiply by 10 is
C minus.
70. Sorry, you need to get like around a 49.
No, that's a C minus 70.
Yeah, so a little higher than 49. Let's say 55. That would get you around a C.
So you would have to get a 55 out of 150, right?
Yeah, out of 150.
Got
But
it.
again, he just counts it out of 100, not out of 150.
Right, yeah, got it.
Okay. Okay. Is there any particular topic that everybody wants to go over the most? Stable marriage. Yeah, correct. Javanpreet, stable marriage. Okay, 2 people for stable marriage. Pointers, stable marriage.
How about
Okay,
some 8 numbers? 8 numbers would be great.
8 numbers in a cross. Okay. Okay, let's go over pointers. because I can cross out 2 of them here. Then I'll do let's do it this way. I'll do these first. You guys want stable marriage, so I'll do stable marriage. I'll do 8 numbers in a cross. And then we can decide between the other 2 at the end. Okay. In your booklets, you guys can tell each other what page it's on. I think for mine it was 36. Let me see if I can find it. In the Waxman booklets, oh sorry, mine was 43. You guys might be able to, it might be a little bit before or after yours because he changes the book sometimes. Yeah, he gives the hex table on the exam. So let's see this. So Rohan, we don't know exactly what's going to be on the midterm. The missionary question, he might ask you something again, just logic based, but he's not going to ask you to write the entire program because there's just not enough time to do all the questions in the exam and still write an entire program. Okay, page 43, for me, it looks something like this. You guys might be able... And then it says like C out, size of B. And then it also says C out, size of B plus 0. Something along those lines. Okay, it's page 41 for you guys. Good, thank you. Okay, we'll go through this entire thing because it could appear on your exam.
Is that the same thing you did last semester?
Sorry?
Is that the same thing you did like last semester?
This page, yeah.
All right.
Because it's straight from his book, so it shouldn't be a problem for us to go over. Okay. I don't get to this point at all. Okay, that's why we're going over it. For this one, let me see if you have to give an... Yes. I remember him telling us you have to understand why. Yes, you do. Okay, let's try it then. So you have B being a 2D array. So it's a 2D array with 3 rows and 2 columns. So now, when we say B refers to the top row. So it would be B or B plus 0. Does that make sense? Good. Then the second row, we refer to it as B plus 1. And then this one is B plus 2. Good. So far, so good. Okay. Great. Now, he's asking us for the size of B. Now, sorry, rather, I made a mistake here. B plus 0 refers to the first, and B also points to the first. But when I say B, I refer to the entire array, right? The name of the array. So if I say, what's the size of B? Who knows?
24.
24. Can you tell me why it's 24?
Because there's 6 integers and each integer is 4 bytes.
Perfect. Exactly. That's a perfect explanation for the exam. There are 6 integers. Each integer is 4 bytes. So 6 times 4 is 24. That's it. Okay. Well, what about the size of B plus 0?
That'd be 12.
That would be, why would it be 12?
I think.
You're just multiplying it by the first one. Wait, no, not 12. 8.
Yeah.
8. Good. You have b plus 0 refers to, let me use a different color, refers to this area over here. Okay, the first row has 2 integers in it. So 2 times 4 is 8. Excellent. Okay. What about size of the dereference of b plus 0?
Also 8.
Why?
Because now we're talking about the integers inside of the first element of the array, which is another array. So it's the size of that array.
Not quite, no.
Mm-hmm.
Okay, let's talk about it like this. What is a pointer?
Wait, I have
Who
a
remembers what
question. I have a question. Like when I dereference something and I put it like in my compiler, it just like shows an error. So like how would it not be an error here?
How would what not be an error?
When you put that star before the b plus 0, how would that not be an error?
This star?
Yeah.
Well, we're gonna get into this question right now. So, give me 1 sec. Yeah, so depending on the system you use, sometimes it considers integers to be 2 bytes, sometimes it considers integers to be 4 bytes, but then that affects everything else. So it depends if you use I think it's a 32-bit PC or a 64-bit. I think for his purposes, integers are 4 bytes always. Yeah. Okay, perfect. Okay, a pointer is a variable. Pointer is a variable whose value is an address. Okay, that's all that is. So a variable, everybody knows what a variable is, right? Like X, Y, Z. And then all it has is just an address. The address is in hex. Now, b plus 0. What is b plus 0, b plus 1, and b plus 2? They're all pointers, right?
Yeah.
Good. Because they're all pointers, I'm dereferencing a pointer. Which means what? What will my value be? What's the value going to be if I dereference the pointer?
Whatever the pointer is pointing to.
It's going to be an address.
Yeah.
Okay. So essentially what I'm doing here is I'm taking the size of an address. Whatever that address may be, it doesn't matter. Okay. What's the how many bytes is an address?
Is it 8 bytes?
8, exactly. This is something you should know if you don't already. Addresses equal 8 bytes.
Why would it not be 8 times 2? Because there's 2 things. I mean, there's like 2 elements in the first part of the array.
Right, but this pointer, b plus 0, is pointing to the first row.
Yeah, the first row, there's like 2 integers in it.
Let me put it to you like this. You have an address. Okay, 123 Main Street points to a house with 7 people. It's still one address, even though there are 7 people in the house, right? I'm not multiplying.
Oh, okay,
that.
got it. I got it.
Okay. Okay. Any questions about these 3 so far? Can you say is equal to? No, you can't say that. No. because b sub 0 is only, let me see, b sub 0. Huh. It's a good question, actually. I don't think he would give you credit for that because you're dereferencing a pointer in this case. And that's not the correct explanation for it. Let me see. Yeah, it's context dependent. Let me give you another example. For example, I can say, and then I can say, okay, this star is used 3 different times, right? The context of when this star is used gives it a different meaning. For the first one, the star is used to initialize a pointer. For the second one, what is the star used for? Good, times, multiplication. Excellent. And the third one, what is the star used for?
Is dereferencing.
Dereferencing. Excellent. Dereferencing. One star can be used for multiple different things, right? We call that overloading. So the same thing happens here. It can be overloaded here as well, but you have to understand the context at what it's happening to. You have to understand that b plus 0 is an address pointing to the first row. Dereferencing that would get you an address because it's a pointer, so it gets you an address and then the size of an address. Okay, now there's still 4 more here. So here he's going to give you an address, which I'll give you guys in a second. Here he gives you an address, which he has to give you, or else you're not going to be able to go through the next
Wait,
couple
what C
of
out B
questions.
is B?
What happened?
What C out B is B? What's the answer to that?
Oh, I misplaced that. Sorry. That's what we have to do now.
Oh, all right.
That's what I'm doing down there. And then you have C out. I'm going to say B plus 1. And then C out of ampersand B. And then C out ampersand B plus 1. Okay, good. Now, he has to give you an address, so I'll give you the one that he gave us in our book. He gave us 0012FF68. Great. Okay. So what is B gonna be?
The address.
Exactly. 0012FF68. Okay. Pretty simple.
Wait, why would it be the address? It's just like printing out B.
Because B, as I showed you here, is still a pointer, right? It points to the entire array. And so the entire array's address starts at 0012FF68. This is where the array starts at.
Wait, so
Okay.
what if I would do like B plus 0? What would I get?
If you do what? B plus 0.
Just write B plus 0. Like B is B plus 0.
You'll get the same answer as the address of the array, probably.
You would get the same answer, yeah. Because B plus 0 also points to the B plus 0 points to the first row, which happens to be the beginning of the array.
Would it be the same thing with B plus 1 also?
No, B plus 1 would be
No.
different, and we're going to get to that in a second. But B and B plus 0 would have the same address.
Got it.
Okay. So now you asked about b plus 1. So b plus, I thought it's two-dimensional. B holds the address of the first array. I thought it's two-dimensional. Give me one sec. Wait, I thought it.
No, I
It is
think,
holding it.
yeah, it just points to the same place where b plus 0 points.
Yeah, they're
Yeah.
pointing to the same place. Exactly. When you dereference, doesn't it give you what is stored within that address? Which part are you talking about, Josh? I'm not dereferencing anything here. B plus 0 is the same address as B. Meaning it has its own address, yes, because it's pointing to the first row. Correct. B is the entire array. But they both, when we say point, we're talking where it points to the beginning, right? It's not pointing, for example, a house can start, say the house address is 123 Main Street. Okay? This points really to the beginning of the house, the edge, right? Because over here, it could be 1 Main Street. About that. We only care about the beginning. This is where the address is, the beginning of the house. B plus 0 is a pointer with 8 bytes, but it also points to a row that has 2 integers, which is 8 bytes. Right, but if I'm dereferencing a pointer, I get an address. I'm not getting the values in that row. We'll reference the one. When you dereference, doesn't it give you what's stored within that address? No, you're thinking of dereferencing the address. That will give you what's stored in the you have to dereference twice is what you want to do. Which do that. You can't dereference twice. You can't, however, find the address of something twice. That wouldn't work. I still don't understand. What do you?
I have
Okay.
a question. How do you know when you're dereferencing an address and when you're dereferencing a pointer?
Depends on how it was initialized. So here I'm initializing a pointer. If I have an address, then it would be something in hex, for example. Does that make sense?
Can you repeat it again?
Yeah. So your question was, how do you know if I'm dereferencing a pointer? How are you referencing an address?
Yes.
So in a pointer, this
Your mic is cutting off.
they say it equals oh, sorry.
Can't hear you well.
Yeah, your
Okay,
mic is
sorry, my
cutting off.
connection's a little bad. Is it better now?
Yeah.
Okay. If not, I'll use a hotspot. But here you have a pointer that's pointing to an address, right? And H.
Yeah.
If I say, let's see, I say C out PTRX, it's gonna print an address.
Wait, I have a
Right?
question.
One sec. If I say C out PTRX, it's gonna print out the address, right?
Mhm.
What if I say C out PTRX like that? What is it going to print out?
The value of age.
Exactly, the value of age. Okay, because the first time I'm just printing out an address, the second time I'm dereferencing that address. Does that make sense?
Yeah.
Okay, I have more examples of that pointers. I'll pull them up
I
right
have
now.
I have a quick question.
Yeah,
What happens if I just do int start PTRX equals H without the and? What would happen?
that would be wrong. That would be wrong. Because
Like, what would
this,
happen though?
you just get an error. This over here tells me I want to initialize a pointer, which means that the compiler is expecting you to give an address of a
Oh,
variable.
got it. All right.
Because remember, I think I wrote it down somewhere here. A pointer, yeah, here it is. A pointer is a variable whose value is an address. Okay.
Yeah, and then if you put the star before it, it just prints out the, what's it called? Just like the number that H is equal to, right?
Exactly. So here I have an example for you guys, and we can run. I think this will give you guys more clarity for it. Int x equals 25. Int star ptrx equals ampersand x. So we see out and x. We see out ptrx. We see out and ptrx. And we see out star ptrx. Okay, so these two are just initializations. What about the other four? What comes out of and x?
That would be the address
The address of what?
of X.
Good. Address of x. What about ptrx?
It would be the same thing.
Good. Again, the address of x. Excellent. What about and ptrx?
You're gonna print out the address of the pointer x, right? No,
I think it would be an
pointer, just a
error.
pointer, just a pointer.
Wait, wouldn't it be an error?
No, it's not gonna be an error, and it's not
error.
what
It's
was
not
the
error.
other one?
I said it was gonna print out the address of whatever ampersand PTRX was gonna be. That's gonna be just the first row.
No, it's just gonna print out the address of ptrx of the
Okay.
pointer itself. Because remember, pointers are still variables, and all variables have addresses.
Okay, so I was right when I was talking about the address of the pointer. Okay.
Yeah. So it's gonna print out the address of a pointer because a pointer itself has to be stored somewhere in the computer's memory. Okay.
Question, Roy. Would Waxman's exam make us write the full address, or?
Yeah, and you're gonna also have to add the addresses too.
Okay.
Using hex, which once I finish going over this, I'll be able to give you guys an example of that also.
Okay. Thank you.
So, what about C out star PTRX?
That would be 25.
Excellent, because I'm dereferencing the pointer. The pointer PTRX points to an address, okay, and I'm sorry, that's H, and I'm dereferencing this address. So you can either say star PTRX, and then that would get you 25. That's what's being held at that address. Okay, perfect. Now, back to this one over here. Okay, does this make sense to everybody first before we continue?
Yeah.
Okay, if anybody has any questions, just feel free to either unmute or put it in the chat. But let's go back here. So now we want to say C out B plus 1. So B plus 1 is going to be an address of the second row, though. Now, second row over here. Let me do it in black. Second row is over here. The second row is going to be what? It's going to be how many bytes after the first row?
8.
We do the address plus 8.
8. Exactly, perfect. So it's going to be 8 bytes after. So what you do is you're going to add 8, but you have to do it in hex. Okay? So remember, you have to convert 8 to hex. Whatever, let me see what 8 in hex is. 8 in hex is still 8. So that's fine. But what you have to do is you have to do the address addition plus 8. Okay? Now here,
What if the number is
have
like
to add in
16 or
hex. So
something?
if the number is 16, then you convert 16 to hex.
How would I do that?
Just divide by 16, which would mean it's should be
1.
it should be
2.
I'll tell you
16
right now.
divided by 16.
16 divided by 16 should be 1. Yeah, 16 in hex should be 1. The way you do it is this way. I'll show you. You have 16 to the first plus 16 to the 0, and then if there are anything more, like 16 squared, that's what that would be. So in this case, there's 1
So it
16.
would be 1
0
times
that.
16 plus
So
0
it would
times
really
16,
be 1 0.
which would just be 16.
What do you mean it would just be 16?
Because 1 times 16 is 16.
Right. That's to bring it back to decimal. You have 16 in decimal form, or you have 1 0 in hex form.
And that's 10.
Correct. 10 in hex, yes.
So I would add 10. Like 10 is too high for hex, isn't it?
No. It goes
Okay.
after 10, it's A, B, C, D, E, F.
Oh, okay.
Okay. So, but that's only if it's 10. We'll get into converting into hex in a sec. That's the next it's coming up. So here we add 8 plus 8, and he'll give you this chart on the exam, but you do 8 and 8, and so that's going to be 16, which is just as we did before, 10, and then 6 plus 1 in binary is 7, and then everything else is just 0, so it stays the same. And so this is the new address that's being printed out. Does that make sense? Go, Karen.
Can you go over an example where you add 12 bytes?
How many bytes?
12.
Like specifically 12? I can do, sure.
Yeah.
So you want to convert 12 in decimal to something in hex. So you do the same method. You do
Is it C?
What happened?
Is it C?
Should be C actually, yeah. A, B. A is 10.
Can you
B
show us
is,
how to do it though?
yeah.
Alright.
And then 16 to the 0. So you still end up with 12, okay? But in hex, you have to know. Say you have 9. So after 9, let me just do 8 also.
Wait, why
8
is
is
the
8.
1 being multiplied by the 16?
Because there's nothing, because 12 divided by 16 doesn't get you a whole number here.
Oh, okay.
So then after that, for decimal 10, 11, 12, 13, 14, so on, you have A, B, C, D, E, and then F. So this is just going to be 15. So if you look at 12, it's going to be C. Does that make sense?
And then he gives us like the whole graph to like add it up, right?
Yeah, he's going to give you the chart to add it up. Do we need to convert, or we can just... No, you have to convert first. If you don't convert first, you're going to get the wrong answer. Okay, and I'll just tell you guys right now, this example will show you that, okay? Let me erase it. Does that make sense for whoever asked about the 12 being C though.
Yeah. And then
Okay.
when we added, do we add 68 plus 12 or just we go one by one?
You add plus C.
Oh, I mean plus C. So we
Yeah,
8
you
plus
added
C,
plus
right?
C. Yeah, and 8 plus C, I can check the chart for you. 8 plus C is going to be 14. Let me see if I can find the chart online so you guys can see what I'm doing. Hex edition. Yeah, here. This is the exact chart he gave in my book. There. That's the exact chart. Oh, sorry, I sent it to one specific person. Let me resend it. There. Okay. You guys should see it now in the chat. Yeah, the meeting's recording is going to be on the Learning Commons website. Okay, so you'll be able to watch back whatever you missed. Okay, so that's what I'm doing with the chart. All I'm doing is I'm just looking at the top, right? The top row. Say I want to find 8, and then I'm looking at the column on the side, 8 plus, and then 8. I see where they intersect, and they intersect at 10, which is 1, 0. So that's why 16 in binary is just going to be 1, 0. Make sense? Okay, great. Now, good. We added that. Okay, so let's move on to the next one. And just again, remember, I'll just give you this example one more time. Don't do this. Don't say, oh, 8 plus 8 is 16, 7, FF 2, 1, 0, 0. This is wrong. Okay, because you did not add in hex, you added in decimal. And that's wrong. Okay, so don't do this. It's going to be posted on the Learning Commons website. Okay, somebody asked, how do I add it? Scroll up in the chat. Here. There's a hex chart. He's going to give you that on the test. So you don't have to do n by yourself. Great. Let's move on to ampersand B. What is that?
That would just be the address.
Good. Which address are we talking about?
0012FF68.
Good. What if it's more than 9? Do we need to convert or can we use the chart he provides? Okay. If it's more than 9, then you use the chart and the chart will show you after 9 comes A, B, C, D, E, F. If you want to add A plus A, for example, that's going to give you 14. That's where the two. So I would suggest using the chart. It's just going to help simplify everything with conversions and addition.
Wait, so how many
If you have a
points would a
different
question
method,
like this be?
like this whole thing is probably one question. It'd probably be worth 20 points. But
20
again, he's going to ask you for explanations with these. So if you don't give the explanation, like the answer is completely irrelevant.
Like, how would I get an explanation for that? Like showing the
Explanation
work.
for what?
Like, how would I like write an explanation for this? Just like show the work?
When you say this, which part are you referring to?
Like the whole thing.
Well, it's going to be broken down into parts. Like this is going to be A, this is going to be B, this is going to be C. Okay, and then it's going to say like, oh, what's the output for A, and explain.
So you would just, how would you explain that?
Here you would say you have 6 integers. Each is by, so 64 equals 24. Like that. Okay.
Yeah.
And you have to do the same for all of them. Okay.
How would I explain the addresses?
Ola, it would be 1 through 9 are numbers, and then 10 through 15 are corresponding letters.
Yeah, I just realized.
Okay. Perfect. Okay.
Wait, and how would I
This
explain
one.
it for the addresses?
You just say ampersand refers to getting the address of something, right? This one again, this is just printing out the address of the array. This is printing out the address of the second row.
And that would just be like a good enough explanation.
That would be fine. Yeah. Again, the lab professors are grading about 400 of these papers. They don't want to be reading essays at the same time as they have to grade all of this. Like, it's just not something that they want to
got
do.
it. Thank you.
Okay, no problem. So, okay, let's do this last one. I need some more space here. Give me 1 second. I'm just gonna move this. Okay. So we have C out ampersand B plus 1. Now this is something different. I'm not sure if you've seen it. Yeah, keep your explanations brief. Exactly. I'm not sure if Waxman has showed it to you, but when you have something like this, it only happens with an ampersand. Okay, first of all, 2D arrays in a computer are really represented just as a 1D array. Okay, so you have 1, 2, 3, 4, 5, 6. Okay. Okay, so right here is B and also B plus 0. Right here is B plus 1. Right here is B plus 2. Okay. If I ask for ampersand B, it would give me 0, 0, 1, 2, FF 6, 8. If I add for ampersand B plus 0, give me 0, 0, 1, 2, FF 6, 8. Okay. They both point to the start of the array. However, B points to this. B refers to all of this in dark green. If you guys can see that. B refers to all of this. B plus 0 only refers to the light blue. Does that make sense?
Yep.
Yeah.
Great. Now, if I say ampersand B plus 1, what I'm doing is I'm taking the address of B and I'm finding the next available space, meaning I'm skipping over the entire length and going straight after it, as if I want to place another array of any size that I want. It doesn't matter. But
So
this
would you
plus
basically
1,
add that by 24?
exactly. So here I'm adding 0, 0, 1, 2, FF 6, 8 plus, now I'm not adding it by 24 because I have to do it in hex. Okay, so
you would convert it first, right?
Exactly. So 24 in decimal equals what in hex? Let's find out. So we'll do 16 to the first. And then here I have 16 to the 0 power. So how many times does 16 go into 24? It goes in 1 time. How many times? Now I have a remainder of 8. So it's really 1, 8. Okay? That's it. I just stick the two numbers together.
Well, you need to convert that also though. The 1, 8.
No, you don't. This is in hex.
So think of
doesn't
simply
that
like
go up until
so think of
15?
it simply like modulo, right? Like 1 8 would just be how many times to 16 going to 24 one time. What is your remainder? Your remainder is like 1 8. That's how you should be thinking it, like modulo.
Exactly. This isn't 18 how we think of 18 in decimal. This is 1 8, right? Like in binary, it's 1 0, not 10. It's 1 0. Make sense?
Not really, because like it goes up until 15, and that's 18. It goes like until F, basically.
Okay, let me ask you this. In binary, what does it go up until?
10.
No, binary.
I don't know.
Nine.
I didn't take
1.
240.
No,
Oh, no,
binary is only
it's
zeros and
zeros
ones.
Yeah.
Yeah, it's only
Exactly.
zeros and ones.
Like
Exactly.
11.
So I can have 11 in binary, but it's really called 1-1. What would this be in decimal? If I wanted that in decimal, what would that be in decimal?
3.
Exactly. This would be 3 in decimal. Exactly. We refer to them, Harel, we refer to them as individual digits. No digit can be greater than 16. That's what we mean. When we stick the two numbers together, it can be greater than 16. Meaning 1
They
8.
basically treat it as a 1 and an 8.
Exactly. And both of those numbers are less than 16, so it works. It's fine.
Okay, so when you add it up, you would add 8, 1 first, and then you would add 8.
What do you mean I would add 1 first and then 8?
Because like you're basically treating them as two separate numbers, right?
Meaning when I add it here, you mean?
Yeah.
No, I would add it the same way. So 8 plus 8, but 8 plus 8 in hex. So 8 plus 8 in hex gives me 10. 6 plus 1 in hex is 7. 7 plus 1 is 8. And then FF2100. So this is going to be the address that goes here.
Wait, what if it's 20 then? What would be the case?
20 in what? 20 in binary, 20 in decimal, or 20 in hex?
In hex.
Okay, 20 in hex.
2-0, basically.
Okay, if you're saying 20 in hex, let me do it on the side here. 001. What was it? 001.
2 F E 6 8.
So plus 20. So again, you just add it in hex. 8 plus 0 is 8. 6 plus 2 in hex is 8 also, and then everything else stays the same.
And I would not have to convert it back again, like in hex, right?
This is in hex. Addresses are in hex. So you can only add hex and hex numbers.
All right, got it.
Okay.
Thank you.
Perfect. No problem. Okay. So that finishes off with pointers, dereferencing.
I have another question.
Yeah.
So since it says reference b plus 1, you add by the total number of bytes the array has, right?
Correct. So you're adding by 24 because B is of 24. Exactly.
Okay, what if it just says b plus 1 or b plus 2? You just add the number of arrays in that row, right?
If it said ampersand B plus 2, like that.
No, not the ampersand, just b plus 2.
If it said, let me see if I understand. It said C out B plus 2.
Yes.
Then you would print out the address. You print out the address of this.
Oh, okay. I get it now.
Okay.
Okay.
No problem. Okay. Any other final questions about pointers? Let me see. If it says ampersand B plus 3, then you're adding 72 in, but you would have to convert 72 into hex first. Because it says if you're finding the next available space, but 3 spaces ahead. 10 is 10. Yeah, Mariam, it is. Actually, in that case, okay, James, thank you. Okay, I think I got everything in the chat. If I didn't, just feel free to unmute. Yes, they're both addresses, but they're not the same address. Exactly. Okay, so we have about 45 minutes left. We finished this. We basically did converting, so I'll take that off. We can either do 8 numbers in a cross or stable marriage. I'll take whatever the consensus wants.
Stable marriage.
Yeah, I'm seeing everybody really wants stable marriage. We can do that, no problem. Okay, fine. Let me just pull it up in my book so I have the code, because I don't remember how the code specifically goes, but okay. Here it is. Okay, fine. Let's do it. You have stable. You have stable marriage. Great. Now, let me see what it says. Okay, let's write this out in words first, and then I will explain it to you. So, you say, if the current man prefers the new woman to his partner, and the new woman prefers the current man to her partner, we have an instability. And the same goes for the new man. If the new man prefers the current woman to his partner, and both have to be true, the current woman prefers the new man, right? Because he can prefer her, but she doesn't want him, prefers the new man to her partner. It is unstable. Okay, great. So now, okay, so now you just have, it's a very simple code when you just understand what every current man, new woman refers to. Okay, so you have the OK function, returns true or false, so bool OK, and it takes in a couple of things. It takes in an array size B and the capacity C. Okay, and then he'll usually give you, you know, the men's preference. That's 0 to 1, 0 to 1, 1 to 0, and this is not supposed to be there. Okay, and the same thing with the woman's preference.
Doesn't matter how we write the array, like in what?
No, it
what
doesn't.
order?
It doesn't matter how you write it. You can write it all in the same row if you prefer. I just like doing it like this for a little bit more neatness. 1, 2, 0, 1. Okay, perfect. So he'll usually give you those, and we're not going to go so deep into how to figure out if somebody prefers somebody or not. I'm going to explain to you more so this portion right here. Let's look at the first one. If the current man prefers, so Waxman told you something about this. When we prefer somebody, do we rate them high or low?
High.
Sorry, I couldn't hear.
High.
No, we rank them low.
Oh,
Right? If you rank somebody as 0, you want them the most. Yeah, 0 is the best, exactly. If you rank somebody as
oh,
2, you want them the least. Okay, I know it's a little inverted, but
okay.
just how the code works. So I can write that down here. 0 is best, 1 is medium, 2 is worst. Okay, great. Now, how do I say current? Current is just going to be C. C equals current. And I equals new. Okay, so far so good. So far so good.
Yes.
Okay, perfect. Just okay, perfect.
Wait, so on the test, we're just gonna have to write the function for this, right?
Yeah, I don't think he'll make you write yeah, he probably won't make you write the entire program.
And how many lines of the function? Like how many lines of code is that?
The entire function, it's the same main function as the 8 queens. You just change the parameter from 8 to 3. Like that's it.
It's literally the same exact function.
Yep. All of these are almost the
Just
same
change the
exact main
numbers, right?
function. Exactly. Just the OK function is the only thing that's different.
Oh, got it. And we don't have to write the OK function, right?
The OK function is what we're writing right now.
Oh, so that's like the different function basically.
Right. The OK function.
So
is
we
what's
basically
in
have to
the-
memorize both of them, right?
Yeah.
Okay.
Okay. Good. So, okay, when we're talking about the man, we speak about the man's preference. So, if the current man prefers the new woman to his partner, and the new woman prefers the current man, then we have an instability. Okay, so let's write that down. Oh, where is it? Okay. So again,
Can you say that
say
again?
if. Say what again?
What you just read.
I just read it from up here. This first portion.
Okay.
Okay, now we're just going to write it in code. So we use an if statement. If the current man, C, okay, this is the man, the current man prefers the new woman. So a woman is always going to be the position inside the array. So B sub I, new woman. If the current man prefers the new woman to his current partner, so we're still talking about the current man, and his partner right now is the current woman. Okay, and I want to say two things. And the new woman, this is the new woman, right? If I'm speaking about women's preference, the woman comes first. If I'm speaking about the man's preference, the man comes first. But the woman is still, again, within the array, within a secondary array. If the new woman prefers the current man to her partner right now, which is the new man, then we have an instability, which means we return false.
This is basically
everybody-
means unstable, right?
This is unstable, correct? Because they essentially want to cheat on each other. They mutually want to leave their partners. So it's an unstable marriage. Now,
If only one wants to, would it be stable?
no. Yes, sorry. If one wants to, it would be stable because it doesn't pass this and condition.
All right, got it.
Okay, anybody have any questions about what I wrote?
The B, so inside the new woman, where you go where it's the WP sub B sub I. I just want to know where that's pointing to. So the B is the arrays that we're taking into the function, right?
Yep, the array that we brought in right here.
Yeah. So what is it an empty array, or is it like, what is the array from the main function that we're taking in this case?
That function, okay. How do I explain it?
Oh wait, yeah, wait. I see. So this is it's just the value. We're just putting in the value from that array into okay, I see. But what is the array? Yeah.
Exactly. So it's initially empty, and then as you move through the program, you say, okay,
Mhm.
is this good? And you say, okay,
Mhm.
no, it's not good. So you'd say, okay, can I put a 1? Right? Then you go to you don't have a go-to, but I'm just gonna write, you go to okay. Okay, for example, and you check, can this work out? Right? Can so this is the 0th. So you just plug in 0 for the I, and B sub 0 would be 1. Okay, and you just continuously check through. It's just like with the 8 queens array. You want to see if these positions are good. So say you have 0, and then you have 7, you have 3, you have 4, and you want to fill in this one with a 5. So C equals 5, right? 5 is what I want to put here. And you're going to be checking. You're going to say, okay, would the OK function pass if I put a 5 there?
Okay. So the first, the B array is just, it's modified in the main function, or is it just values of 0 to 1?
No, it's going to be
Or
modified
sorry,
in the
0
main
to,
function.
okay.
Yeah, and the B function is what we're going to be printing out, because it's going to be our solution. So I think this one only has 2 solutions. I think it's like 1, 2, 0, and what's the other solution? There are 2 solutions to this. I'm forgetting what the 2 solutions are. Yeah, it should be like 1, 2, 0 and 2, 0, 1, or 2, 1, 0. I'm forgetting them, but yeah. There should only be 2 solutions to this equation, and these are held within the B array.
Okay, I see. Thank you.
No problem.
Wait, I have a question.
Yeah.
So for that if statement that you just put, wouldn't you need like a for loop before it? Because like you're putting I and C in it.
I think the for loop doesn't happen here. Give me one sec. Yes, there's a for loop above these 2. So there would be a for loop somewhere here.
And what
It'll
would be
just
the
say
for loop?
int I equals 0, I is less
C?
than C, right?
And then
Because
I
C is the
plus.
current position where we're at, I plus plus, and then you just check if it was used. If
And then like this is the if statement basically, right?
yeah, if B sub I equals B sub C, meaning if we already matched this partner, then return false.
That means it works. What does that mean?
No, that means it doesn't work.
Okay. And then would it go down to this if statement?
Yes,
I'm
the
getting
for
it.
loop goes for all of
Okay.
these statements.
Wait, I really don't understand. It's like really messy. So like this for loop is for that black if statement, right?
No, the for loop is for all the statements. Here, if it's going to be for this if, and for the next if we're writing.
So it's like one big, it's like 3 different if statements for that one for loop.
Exactly. The for loop is going to iterate through all of this. Shoot, sorry. Give me one second. Equals sub C, return false. Good. It's going to go for all of these. So this one for loop is still going on for 3 if statements, which we can do. We've always done that.
And then what's the third if statement?
We're about to work on it. Okay, but I just want to make sure everybody understands this second if statement before I move on to the third one.
Mhm.
Okay, perfect. So the third if statement, we talk about if the new man, so again, we're speaking of the new man. So if the new man, remember in men's preference, the man comes first. This is a new man, prefers the current woman. Remember,
Wait,
a
isn't
woman
I
is-
for the woman and C for the man?
No, I is for new, C is for current.
Oh, okay. So if the new man prefers the current woman,
Good,
Yeah,
current
did
woman,
you-
exactly. Good. To the new woman, obviously, because that's his partner right now. So MP of I to B sub I. And we have two conditions here, and it has to be reciprocated. And the current woman wants the new man over her current partner. Then we have an instability. And we
and that's
return
also unstable.
exactly. And we return false. Now, if I got out, this is the for loop. If I got out of this entire for loop, I return true.
Wait, I have a question. Could
Yes.
I put that whole like these three if statements into like one big if statement or no? Like they all return false.
If you can.
Would it
The
be
question is
possible?
how you,
What?
I'm thinking right now. Actually,
You can put the two last
you
ones.
could, it would be very messy.
Yeah, but it would be
You
nice.
could, you would say this.
So
You
it's
would
just better
say,
to put it
I'm
like
not gonna write
that.
the whole thing. You just, yeah, it's better to put it like this. But you say if, and I'm going to call this number.
Oh, and you
one.
put
This
the
is
or
one.
between them. Okay, okay.
Yeah, using or, I
Yeah,
felt
and then
like
you say,
it was able to compact everything else entirely.
or 2 or 3, right? Because the 3 has an and inside, and so does the 2. The 2 also has inside. I would probably put parentheses over these two. But if
So if it
1
dodges
or
these
2
three if
or
statements,
3,
it
then you
basically
return.
just returns true. If it dodges
If what?
these three
What
if
returns
statements,
true?
it just like returns true.
Yes, then return true. Exactly. You're out of the for loop, return true, and then you just close the function.
Right.
off.
Got it. Wait, could you like bring it up a bit? I just want to take a picture of it. Like zoom out a bit so I can take a picture of it. That's too much.
Do you want just the if statements? What do you want?
Just a for loop in the if statements
Okay.
and the array. Also the array. Yeah, that's it. Okay, that's good. Thank you.
All right. Does anybody have any other questions about stable marriage? If not, we can go to 8 numbers and across.
So that's all I need to write for the stable marriage, right?
Well, meaning I don't know what he's going to ask you on the test.
Like if he
But-
asks that on the test, that's all I write, right?
If he asks you for the okay function, then yes, that's all you have to write.
Okay, and how many points would I get for that?
A question like this, I would assume, is probably 10 points
10 points? That's it?
because you're just writing the okay function that he gave you in class. You're not really doing any thinking for it. It's just
Oh,
memorized.
you gotta memorize it.
Right. There's no thinking involved. For a riddle, he might give you 15 points or 20 points, or for something like pointers, because there you actually have to think. It's not something that you're just memorizing and regurgitating back to him.
So what if I get all the riddles wrong and then like all the memorization stuff correct? How much would I get?
Usually his tests are about 60-40. So 60 of things that he taught you in class, 40 riddles. So if you get everything correct with explanations and nothing wrong, you would probably get a 60.
60. So, and then like, that would come out to like a 75 or something.
Yeah, should be maybe a little higher than
Right.
75.
Right, thank you.
Okay. Do you guys want to go over 8 numbers in a cross, or is there a specific question or topic you guys still want to go over? I'm more than happy to adjust. 8 numbers. Oh, 1 second. I didn't get a chance to read the chat. Let me do that right now. How many questions in the exam? So around anywhere between, I've never seen more than 15, but he could also go lower. He can also give you 10 questions. Is he gonna ask us to write the array? I'm not sure actually. He hasn't asked us in the past to even try writing the array. He's usually just given it to us. But he could, I guess he could, if he really wants to. Maybe that could be like a riddle. Write one that works. What does the first if statement do again? The first if statement follows this pattern right here. If the current man prefers the new woman to his partner, oh, you mean this if statement over here? Think of it as the row test that we did for 8 queens. It's the same exact idea. Okay, we don't want to have like 1-1 because we can't have that, right? Then that means that 2 people want the same person, which doesn't work. That's an instability. We want to find the stabilities. We want to find the stable marriages.
I have another question. What if I just get the array part right and then everything else wrong?
1 second.
How many points would I get?
What array part? This part? The green?
Yeah, just that part correct and then everything else wrong. How many points would I get?
Well, he usually gives you the array itself.
I think a better question is, does he like, does it matter if the code is completely correct or if just some like concepts are like correct? So let's say we got like 2 of these for loops correct, but we like did something wrong on the last one, or sorry, if statements, but we got something wrong on the last one. Like would it like just deny the whole
Yeah, so that depends on the lab professor grading it. What
okay.
ends up happening is that, say there are 15 questions, each lab professor / TA gets 2 questions that they grade. Then what ends up happening is that every lab professor has a different grading system. So one lab professor can either mark it right or wrong, like black and white. There's no in between.
Okay, so it just depends on.
Right, another lab professor, because what the lab professors have to do is if they give you partial credit, they have to give everybody else partial credit. So it's sometimes they're very iffy about that, but I've seen lab professors who will like give you 3 out of 10 points for just like trying it or like writing something reasonable. So it's just very lab professor dependent.
Okay, thank you.
Okay, thank you, Kathy. Okay. Okay, perfect. So let's do 8 numbers in a cross. We're mainly going to focus on the helper array for that one. I just have to pull it up. But yeah, we're mainly going to focus on the helper array for that, unless somebody has a specific question about the actual program itself, which I'm more than happy to answer any questions about. So let me see. This is 2. Was this before stable marriage? I'm just trying to find it in my book. Oh yeah, okay, fine, great. So you have this cross. It's supposed to be a helper array, right? It's any numbers between 1 and 8 inclusive. And he wants no 2 adjacent squares to contain consecutive integers. Okay, what does he mean by adjacent squares? He means you can't have anything vertically, horizontal, or diagonal That's at least a difference of 1, okay, in either direction. So for example, 1 can't be next to 2. 3 can't be next to 4 or 2. Okay, does that make sense? Great. Now, I'm assuming he just wants you to write the okay function for this. But yeah, if anybody has a question on that, we can definitely go through it. So, okay, 1 second. So, we'll say bool. Okay. Int B. Int C. And then you have a helper array. 8 rows by 5. Okay. And so, did he teach you he taught you what a sentinel was, right?
The sentinel was the -1, which is like your stopper.
Yeah. Good, the stopper, exactly. So in this case, we'll just say it's -1. Excellent. Okay. So
Wait, why is it by 5?
y is what by 5?
The array, like 8 by 5.
Oh, because at most, a square can be, I'm assuming, next to 5. I think we worked that in class, and that's just how it was. We'll run through it and see if it's correct, but I think it should be 8 by 5. So you have this, and then you have this. Okay. So here's the thing. He can number these any way he wants. So you can say this is 0, this is 1, this is 2, this is 3, this is 4, this is 5, this is 6, and this is 7. Right? Okay. So when you write the array, you start at the 0 position.
Wait,
So right here.
2 is equals to 8, I think.
Sorry?
2 and 2, I think they're adjacent or something like that.
No, meaning the numbers inside can't be adjacent.
Oh, okay.
Okay. Good. Let me just make sure I'm not doing this wrong. Okay, good. So the 0th position, I can put any number there I want, right?
Mm-hmm. Yep.
Good. So I just put the sentinel. The second rather, the second one. Do I have to watch out for any neighbors?
Just for 7.
Just for, no, we didn't get to 7
No,
yet.
there's
0?
not 7. It was 0.
Good.
Oh,
0.
0, right? Because I didn't get to 7 yet. Remember, this is all going to go through a for loop. So I only have to go through the neighbors that something at. And the only one I place something at is at 0. Then it's -1 for the sentinel.
I think the best way,
What
I think one
about
of the
at,
Professor Yun Wang spoke about it. It's like if you draw it into a one a box going horizontally, and you don't have to worry about the numbers on your left, not the right, not after. It's kind of funny because that's how she puts it.
boxes on the left? Right, you only have to worry about the boxes on the left, not the right. But Waxman can label it however he wants.
Yeah.
Okay, so this is for 0, this is for 1. Let's do 2. For 2, what do I have to worry about?
You have to worry
1?
about 1
And then that's it.
and then -1. Yeah.
Good. And for 3, what do I have to worry about?
You have to worry about 1 and 2.
0, 1, 2.
Yeah, 0, 1, and 2.
Excellent. 0. Good. He'll probably want you to write it in ascending order. So 0, 1, 2, and then -1. Right? If you write 2, 1, 0, I'm not sure if he'll take off points for it, but he'll specify it on the exam for you.
Okay, thank you.
Wait, why not 6?
Because we didn't get to 6 yet. That's why.
Oh,
Right, this is only up to 3. So I'm only worrying about what I did put, right? It's making the computer do less work. Okay, now for 4. What does 4 have to be careful of?
0,
Good. What about 5? What does 5 have to be careful of?
4, 0, 1.
4, 0, and 1. No, 0, 1, and 4. If I want to put it
Excellent.
numerically.
Good. Yeah, I would suggest putting it numerically. It also just helps with consistency. Good. What about for 6? What does 6 have to worry about?
3,
0,
4, 0,
0,
1.
0, 1, and 4. If you want to put it numerically again.
3,
Good. 3 also.
Yeah, 3 also.
Right, 0, 1, 3, 4, and then -1. Excellent. That's for 6. And then the last one, 7. What does 7 have to worry about?
0, 1, 2, 5.
Excellent. 0, 1, 2, 5. 7. Good. And then we close the helper array. Excellent. So now you see we have 8 rows. This is 0, 1, 2,
What's the
3.
-1 for?
8. It's what we call the sentinel. Sentinel is just a stopper. So once I've reached the -1, I know I don't have to continue anymore, and I can move on.
Got it.
Okay, good. Now, how many rows do I have? So I have my first row. Well, let's look at the one that has the most, which is these two. 6 and 7 have the most. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Good. So I have 5 columns, which matches up here, and I have 8 rows. I think it's definitely always going to be 8 rows, right? Because you are always going to have rows. The columns, I think it's also always going to be 5, but just double check it on the test just in case. Okay, any questions about this so far? Okay, so let's move on with the rest of the OK function because that was just the helper array. This is just our helper array.
Wait, so where's the normal array?
What'd you say?
Where's like the normal array? Or is that like the only array?
No, that's the only array for this one.
All right.
We have a for loop. We say for int I equals 0, I is less than c, I plus plus. We say if b sub I equals b sub c. Again, this is similar to the row test and what we've done in stable marriage. And I'm sure you've done it in a bunch of other projects. Just return false, right? You can't have two numbers that conflict with each other because they're the same. If they're the same, it's you can call it unstable, you can call it a conflict, adjacency issue. We've already used that number, so we can't use it again. Each number can only be used once. Then we have a second for loop. Now we have to write it as a separate for loop because the condition is going to be different. It doesn't meet the same condition. And our condition, I'll put it in black, is while the helper array does not equal -1. I can keep going. Okay, because if it equals -1, then there's just no point in me continuing to move on. And then I say if the absolute value of b of a sub c sub I minus b sub c, and we'll go through all of this, equals 1, right? The absolute value takes care of if it's going to be 1 in the positive direction or 1 in the negative direction. Then I return false, it's unstable. Then I just return true if it's able to get past those two for loops. And then I close the OK function. Okay, and then everything else is the same for the main function.
And that's the whole function?
This is the whole function, yes.
All right.
Okay. Now, let's go through this.
Could I just take a picture of it real quick? Also the array.
Do you want? Sure.
Yeah, that's it. That's good. Thank you.
Okay. So, let's take a look at this. while a sub c sub I does not equal -1. Okay, so we're just iterating through all of this at once. So let's just look at this really quickly. This portion right here. B of A, let's pick a value for C. C will be 3, and I will be 2. Okay, this is C, this is I, and then I close this, and then I subtract B sub, and so I said C is 3, so C has to be 3. Let's see what this equals. A sub 3 sub 2. So I go to the third row, right here, and I go to the 0, 1, 2. I go to the second position, the third position, but yeah. And so that's a 2. This whole thing is a 2. B sub 3, however, is, oh, so you have to do B again. This is 0, 1, 2, 3. Say there's a 4 in here. Okay, there's already a 4. We've used the number 4. So 2 minus 4, that's -2. We use the absolute value. That's just 2. This works. Say, however, there was a, which number do I want? Say there was a 1 here. That would cause us an issue because it fails the adjacency test. 2 minus 1 equals 1, and this shows that a neighbor has one difference from where 3 is.
Are you saying that B sub 2 already had the number 2 stored in it?
B sub 2? This, you mean? Up here?
Yeah.
Yeah. So it would have numbers over here where there are stars. Yeah.
Wait, would a question like this have an explanation or no?
Yeah, he'd probably ask for an explanation. Okay. Any other questions about the 8 numbers in a cross? 0, 0. Can we use a while loop instead of a for loop? You couldn't use a while loop because for the for loop here, specifically because he wants you to use this condition over here. I'm trying to think. Let me see if you could use a while loop. While a substitution. Oh, I guess you could use a while loop. Yeah, you could use a while loop. Yeah, you could use a while loop. I don't see why not. Yeah. But just remember, you'd have to iterate afterwards. You'd have to initialize this outside of the while loop in order for it to work. The for loop just does it all for you once. Like Kathy said, it condenses it for you into one line of code. Any other questions about this? Okay, great. So, let's see, what else was there up here? We did 8 numbers in a cross. Okay, we can either do 8 queens, brute force way, go to, or no go tos. Or if anybody has something else that they want to work on, happy to do it. Brute force? Okay. All right, let's do it then. So with the brute force 8 queens method, you have a 2D array. Sorry, you don't
Wait,
have
did
a
you
2D array.
did you do what's it called? Brute force last semester?
What do you mean last semester?
Like on last semester's video, did you do brute force?
I don't remember, probably, but I'm not 100% sure.
then could we do something else instead? Because like whoever wants to watch it could just like watch the last semester's one. Like there's no point of just doing it again, you know what I mean?
However, other people want to go over brute force, so
No, I understand, but like there's already one posted from last semester. You
If
guys
that
could
was
watch
the
that
case,
one.
then we would have never went over stable marriage.
You can leave the call then.
Bro.
All right. I'm gonna go over brute force now. Just in case somebody has a question that they can ask me in person, not in person, rather, on the Zoom call instead of watching the video and being a little more confused. So you have, what is it? You have, it's 8 for loops because this array has 0, 1, 2, 3, 4, 5, 6. Let's pretend that that's 8. You have 8 for loops, okay? And I think he says int q0, int q1, 4. This is Q2, Q3, Q4, and it goes up until Q7, Q5, Q6, Q7. This is brute force. It's like truly awful, but it's 7 for loops, and then the rest of the initializations, conditions, and the increments happen at the end. Okay. Now, the main portion of the brute force is the OK function here. Does anybody remember that OK function for brute force? He started off with K equals 0, while K is less than 8. Right? We're going through everything. We're not just going up until our current position C. We're going up until 8. And so we say, if OK of B, right? We just pass in the B. We just pass in the B array. Then we will be able to, sorry, there shouldn't be a semicolon here. Print it. Then we say if K equals 7, print Q. And then should be good. Okay. Else, if it's not okay, then I just break out of this loop and I adjust, and now I have to close all of these because all of these have open loops. Okay. This over here, though, is the main portion of the brute force. You have to check first the OK function, which is written outside. I can do that for you here. Okay. Int B, it just passes in the B array. And you have a double for loop though. Int C equals 7. C is greater than or equal to 0, C minus minus. And then you have a second for loop. Less than or equal to 7 plus. You're gonna say I is less than 8, either way works. And then you put everything in one if statement. If we already used it, sorry, this should be B. Let's see, already was used. Or you have the absolute value of Q sub C minus Q sub I equals C minus I. Then we just return false. If we were able to get out of both of those, we return true. And that's how you do the brute force way. You have 6 for loops within, hold on, I just missed all these questions. Y C equals 7, not C equals 8. Over here, you mean, right? YK equals 7. Jinsun, I'm a little confused. Are you referring to K or C? C. Where do I put C? Over here, you mean? The initializations? Okay. So remember, you start at 0, 1, 2, 3, 4, 5, 6, 7, right? Arrays are labeled from 0 up until 1 less their capacity. So here it's at 7 I'm starting. And then I'm going down backwards up until 0, including 0. I hope that clarifies it a little bit more. Can you explain that part? Yeah, we use absolute value as a shortcut to check both the up diagonal and down diagonal tests. On the left side, of course. Okay. I think that's about all the time we have for this. Let me see if I'm missing anything else before I call it quits. I can go up to the main part. This whole thing is the main part. I really doubt he's gonna make you write, 6 for loops within, 8 for loops within another. He might just ask you to fill in this part and then write the OK function. Because just writing 8 for loops is redundant and you're prone to making a mistake with 8 for loops like that. Kathy, perfect, she sent it in. Okay, if you guys could take a minute to just fill out the feedback form so we're able to have a session like this for the final, that would be great and really appreciated. I'll put it in again just in case. Right, if anybody has any other questions, I can stay on for a little bit longer. But yeah, if you guys are able to fill out the feedback form, really appreciate it. And the recording should be uploaded. I don't know, it's honestly the weekend, so I'm not sure when, but I would say Monday morning. All right.
Thank you. Have a
You're
great day.
welcome.